This video is about limits and continuity for the functions depend on more than one variables. Okay, why we want to learn functions about more than one variables? The answer is obvious, because in the real world, most of the functions depend on more than one variables. For example, temperature in a room normally depends on 3 spatial variables, and the time easily depend on 4 variables. Okay, why we want to learn the limits? Recall pretty much the first class you learn in the calculus is the limits. Because calculus is about differentiation and the integrations. Both of those two concepts depend on the limits. Okay, now, so what we want to learn here is to find the limit, something like this. xy goes to ab fxy. See what that equal to. What this means? This means here's x, here's y. Okay. Remember, fxy is a surface above, say above this xy plane, for example. Think about here's a point A and B. Okay. So pick the point xy close to AB. Then you can find fxy, okay, in the surface. Then give another one, you find another one. Okay. So 1xy goes to AB, we want to see what about where fxy goes to. Okay. Let me draw you another picture. Okay, fxy is the surface, okay, there. Now, here is AB. You pick xy. You can plug in, you find fxy here. For example, this point is x, y, f, a, b. Okay. So give another xy here. You can plug in there, you got another one. 1xy goes to AB. We want to see what is the fxy goes to. Is approach to that or not? Okay. Okay. So if you want to understand this one better, let's go back to see what is the limit for the single variable function. So x go to a. Okay, say this one. Okay, what this means? Okay, if you understand the single variable function well, then which will be really helpful. Okay. Again, for the single variable function fx, its a graph is what? Is a curve. Okay. Say here is a. Now, say here is L. Okay. So what this limit means? Pick x, you got fx. Pick another x, you got another fx. 1x goes to a, you can tell your fx goes to what? L, right? Okay. Now, for the single variable function, to find the limits, we want to see what? X goes to a from right. X goes to a have two ways. One is from right, one is from left. Okay. Now, this limit exists means what? Okay, you pick x less than a, you find fx. Another x less than a, find fx. 1x goes to a, your fx goes to L. If both side limits both exist and equal, then this limit exists. Okay. Then go back to the case for two functions depend on two variables. So for the given point here, how many ways your xy can go there? As you can tell, it's what? Infinite many ways. So for this limit to be exist, just say doesn't matter which way you go. All the limits must be same, must exist and equal the same. Then in that case, limit exists. So this tells you for the to find the limit for the function depends on more than one variable. It's much more complicated because there's infinite many ways for your xy approach to the point A, B. However, if you can find two ways such that the limit does not equal, then that means your limit what? Does not exist. Just like I use this one as an example. Function depends on one variable. For example, my function like this. Okay, I'm talking about function depends on one variable. So its graph is a curve. Say this point is A. Okay. Say here is 1. Here the height is 2. Okay. For this case, this is my fx. Okay. Obviously, limit x goes to A from left. I put a minus here. So what is that limit? So pick x less than A. Find out what is fx, right? Then pick another x less than A. Find out fx. So when x approach to A, your fx approach to what? 1, right? Give you that. Okay, limit x approach to A from right. Obviously, you are going to see this limit exists 2. This height is 2. Pick x bigger than A, fx. When x goes to A, your fx goes to 2. Okay. And obviously, this time left limit x goes to A from left is not equal to limit x goes to A from right. Then we say what? This limit does not exist. Same idea can apply to function depending on two variables. Find the limits. Okay. For example, we want to show that limit xy goes to 0, 0, x squared plus y squared on the denominator and x squared minus y squared on the numerator. We want to show this one does not exist. Okay. How do we show that? We use same idea as that one-dimensional case. Okay, we're talking about xy goes to origin. Okay, goes to 0, 0. Now, how many ways we can go? You can go here. You can go here. You can go here. You can go there. Infinite many ways. Okay. However, if we can find two ways for your xy to approach to origin, such that along those two ways your two limits does not equal, they both then do not equal, then we can say what? This limit does not exist. Okay. Now here we are going to choose two ways. Okay. The first way is we chose our point along the x-axis. So first way, that means what? All the points xy here what goes to origin along the x-axis. Okay. What do we mean along the x-axis? Every point on the x-axis they have their y what? They have their y equal to 0. Therefore, on the x-axis, your y is always 0. Okay. So in this case, along our way 1, okay? So this limit, if we're along the way 1, this first way, okay? Since this point on the x-axis, so your y is what? Always 0, okay? We chose a special way to find this limit. Okay. So we got x squared. Since y here equal to 0, you got it here. Then x squared minus 0. Okay. Let me tell you something. X goes to 0, not equal to 0. You don't say, oh, 0, I plug in x by 0, undefined, okay? X equal to 0, but not equal to 0. So as long as x is not 0, we can cancel this. We can cancel this, give you 1, okay? So what this means? That means we let xy point approach the origin along x-axis, go this way. Then we find the limit is 1, just like a previous one from left to right. Okay. This is along x-axis. Okay, second, we go with y-axis. Okay. So we pick all the point here. Goes to origin, but along with y-axis. Okay. Every point on the y-axis, they can be written like what? 0 and y, right? Okay. Therefore, along this special path, this limit along this special path, this limit can be written since along the y-axis, so x is always 0, y is changing. Okay, your fxy is x is always 0. This 0 is not because of that, it's because of this. 0 minus y squared, 0 plus y squared. Okay. Now y goes to 0, but not equal to 0. So you can cancel this to give you minus 1. So now we show that this limit, we chose 2 special paths. One is along x-axis, one is along y-axis. You got a different limit. Therefore, we show that what? Limit does not exist. Okay, even you show both ways, they got the same number, doesn't mean the limit exists. Remember, there's an infinite many ways. There's no way you can finish checking that. Okay, another concept is called continuity. Before I talk about 2D function depending on 2 variable continuity, let's look at what do we mean function continuous for single variable function. Let's recall that. If you understand this one good, then you have no problem to understand the continuity for a function depending on 2 variables. Okay. Now, first of all, remember this graph is a curve. Say, here's A, okay? If your curve is like this, it's hard for me to draw that. Okay, I got a curve here. This is an empty dot. This is a solid dot. Okay. Say this point is a 1. Here is a 1/2. Okay. Now, if this is my function, okay, fxy, fx. Now, this is a well-defined function, okay? For example, what is fa? This is an empty dot. So once x is equal to a, your fa is what? 1, right? Okay. What do you think about limit? X goes to a. What do you think about this limit? Exists or does not exist? In fact, this limit exists. You know why? Because pick x, you got fx. Pick another one, you got fx. 1x goes to a. Your fx goes to what? 1/2, right? From right, same thing from left. So limit exists equal to 1/2. Okay, the reason I give you this example means what? Limit exists at a. See, limit exists at a. Does not mean your function. What do you think about the function? Is this function continuous at a? Obviously, it's not, right? So, function exists. A limit exists. Does not mean your function is continuous at that point. So, what kind of condition makes it continuous at a? First of all, limit have to be exist, right? If not exist, like this, obviously not continuous. So limit exists is important. But at the same time, they must equal to what? Fa. So this is the definition. If this is true, then we say function continuous at a. That means you put this point back here. Okay, you put this point back there. So function continuous means what? Limit exists at the same time equal to function value at that point. We have same thing here. If your y goes to a and b, if this one give you fab, then we say this function is continuous at ab. Same thing. Okay, again, find the limit is far more complicated than plug number in. However, if your function is continuous, to find the limit, it's just simply like plug number in. For example, okay, to find this limit, just simply, this is a nice function, okay, it's continuous. So to find this limit, simply like plug number in. Let x equal to 1, see? Y equal to 2, so you got this. 1 squared plus 2 squared. 1 squared plus 2 squared. Give you 5. Okay. Let me say that. For the what kind of function continuous? For the most of functions you deal with, they are continuous. Let me use one single variable function as an example. For example, this function continuous everywhere except what? X equal to 0, right? Except. So the continuity only occurred when those points not in the domain or your function defined piecewisely like that. So most of function continuous at most points. Okay, read the book, okay, important.